Hi, this is Sue McBride, and we are going to be discussing sections 1.2 from the Statistical Reasoning for Everyday Life textbook for Math 157. Our goal for today is to understand the importance of choosing a representative sample and becoming familiar with several common methods of sampling. And what you're going to be asked to do, your objective will be to use the vocabulary you learn to properly decide what type of sampling method is being done, as well as figure out if the sample could be a good representative sample. So those are the objectives you'll be doing for this learning goal. We need some definitions as always. Now you've heard of a census. When they take the census for the United States, that means you're trying to collect the number of people who live in the United States. So a more generalized definition of a census is a collection of data from every member of a population, whatever your population might be. So a good representative sample is one that's going to reveal all the characteristics of the population by looking at the characteristics of the sample members. So you'll want to make sure to get a good representative sample to make sure you really do get the general characteristics of the population. There's several ways to do this. All right, suppose you want to determine the mean height of all students at your school. What's more likely to be a representative sample, the men's basketball team or the students in your stats class? Well, the men's basketball team isn't going to be a good choice because generally they're taller than average. The mean height of the students in the stats class is much more likely because they're more a representative sample of the students at the school and not a specialized subset like a basketball team. All right, now bias is very important to try to be aware of. So what is bias? A statistical study will suffer from bias if its design or conduct tends to favor certain results. There are several ways you can introduce bias. One of the things talking about, you've heard of Nielsen. They're the ones who go out and do polls. They earn money by charging TV stations and networks for the services. Helps figure out the ratings for the TV shows. So if they provide the ratings for the TV shows, why doesn't NBC simply do so on its own? Why do they pay somebody? Well, the cost depends on the show's ratings. The higher the ratings, the higher the network can charge. So if NBC did the study, they would have a clear bias, so the advertisers wouldn't trust what they did. So instead, you find an objective third party, in this case Nielsen, but that third party also has to use good sampling techniques to get a representative sample. So there's several things involved in this idea of getting a sample. So here, this time out to think. The fact that they pay for its services might seem to give them a financial incentive to make it look good. So how does the fact that Nielsen also provides ratings for other networks help prevent it from being biased towards NBC? So that's something to think about, and something we might talk about on a forum discussion. All right, so key ideas in sampling. All right, so here's the main ideas. That study can be successful only if the sample is representative of the population. So that one on the taking the height of the basketball players, that was a bad sample because it doesn't represent the whole population, just a small subset. A biased sample is unlikely to be a representative sample. There was some way that a question was worded, or somebody has a stake or a financial interest in swaying the way the outcome is, so it's unlikely to be representative. Now the last thing is, even a well-chosen sample could still turn out to be unrepresentative just because of bad luck in the actual drawing of the sample. Who knows, maybe there was a flu epidemic going on one day, so there was a whole bunch of people missing from school, and so the sample you got wasn't a really good representative, or maybe there was a field trip. Those kind of things you're not too sure about, so you may plan your best but still have something happen and get a bad sample, which is why statistics is about inferences. It's not real solid, but it's the best you can do. So you try to pick a sample that's representative, you try to make sure it's not biased, and then you check every which way you can to make sure, if it was bad luck, not much you can do about it. All right, so what are some of the sampling methods we can use? Everything is a random sample, so don't key in on that word. This first type is called a simple random. So a general random sample is one in which every member of the population has an equal chance of being selected to be part. So if you put that word simple in front of it, a simple random means every possible sample of a particular size has an equal chance of being selected. So notice the difference between the two. A random sample, every member of the population has an equal chance. With simple random sampling, every possible sample, the sample itself of a particular size, has an equal chance of being selected. So subtle difference. All right, so we're not going to worry about the random number generator on the calculator, but if you want to try it, you can. It's a good way of picking lottery tickets, because you just tell it how many digits you want and it'll pick you some random numbers, which is how those lotteries are actually chosen, just simple randomly generated numbers. All right, so what about a telephone book sampling? If I want to do an opinion poll in which the population is all the residents in a town, could you choose a simple random sample by selecting names from the local phone book? So my solution here is a sample drawn for the telephone book is not a simple random sample because phone books invariably miss a lot of names. For example, the phone book will be missing names when 2 or more people share the same phone but only have one listing, or it's unlisted. And here's the one that I think is the most important. Most of my family, my children anyway, do exclusively have just a cell phone, so they're not even in the phone book. So if there's not a chance for being chosen, then it's not a good sample random. So a phone book just really doesn't work well anymore. It used to be one of the major ways we drew simple random samples. All right, another method is called systematic sampling. Here we use a system such as choosing every 50th member of a population, or the way you say that is every kth member. You've done this in your class where the teacher says count off by fives and you do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Then every fifth person has that number and you can form up groups that way. So every kth member, so you go through the whole population and if you just choose whatever that number is, every fifth, every 10th, every 20th, every 1000th, etc. That's systematic. So for example, if you're going to do a survey of students in the co-ed dorm, in which males are assigned odd and women are assigned even, could you obtain a representative sample when you choose every 10th room? Well, no, because if you start with an odd, you'll only get odd numbers. If you start with even, you'll only get even. Therefore, you would not get a good representative sample. You'd only be getting one gender or the other. So you are using systematic method, but it will not give you a representative sample. So you would want to choose a different sampling method. So if we chose every fifth room rather than every 10th, would that then be representative? So that should work because that would alternate the evens and the odds well. All right. One type of method that is done way too often that's really not a good method is called a convenience sample. I call it a down and dirty, I just got to grab some people and ask what they think, but it's not a very good way to gather data. It's simply chosen for convenience rather than a more sophisticated procedure like one of the other ones we're looking at. So here in the supermarket, they have a new brand of salsa, offers free taste tests, ask them what they think. What type is being used? Well, that's going to be convenience. Is it likely to be representative of the population of shoppers? Well, not really. This is convenience, but it only is the people who are willing to try a new product. I, myself, don't eat salsa because I have a problem with tomato-based acid stuff, so I wouldn't even go over there. My husband would, but I wouldn't. So this is called a self-selected sample, and those are bad. Same thing when you send out a survey by mail and ask people to mail it back in. Again, that's a bad way because it's self-selected. Only the people who A, get it in the mail, B, open it, C, decide to do it, and D, mail it back are going to get it to you. And by then, the response rate is usually very low, like less than 10%. All right, so again, not likely to be representative, and only people who like salsa are likely to participate. Could be useful, however, for the people who do like salsa, are the ones that are going to buy it, so at least you'll get that information. But as far as a good way to get a random sample, it would be a convenient sample. All right, how about a cluster sample? This involves the selection of all members in a randomly selected group or cluster. In a minute, we're going to compare this with what's called stratified. Those are the two people get most mixed up. So let's look closely at cluster. All right, I want to know the mean gas price at a gas station located within a mile of my rental car locations at an airport. How could I use cluster sampling? All right, so I randomly select a few airports. From these airports, I would check at every gas station within a mile. So in other words, I chose a few, but from those few, I got every piece of information. Stratified is slightly different. Stratified involves randomly selecting members from each strata. So in cluster, we sorted, we cut things into subsets, but I only chose a few of the subsets in cluster. In stratified, I'm going to make those same subsets, but I'm going to select members from each of those. So if I've got 60,000 households a month to compile, well, there's another spelling error, to compile its unemployment report due, I'm going to have to write to the authors of this book and let them know I didn't check this for spelling. Interesting. To select these households, the department's first groups cities and counties into about 2,000 geographic areas. So envision something with 2,000 grids on it. If they select households within each of those, then it's going to be stratified. The strata are the actual geographic locations, and it's important because we need to, let's just see what, blah, blah, blah. Because unemployment rates in rural Kansas may be very different from those in Silicon Valley. So by using this stratified sampling, the Labor Department says it gets a fairly good representative of all geographic regions. So if this same one had been done by cluster, you would have still gotten those same 2,000 geographic regions, but you would have only chosen maybe 200 of those and taken all of the people from those 200. With the stratified, I'd look at all 2,000 and take a few from each. Those two are very different. Okay, so let's review our common sampling methods. Simple random, choose a sample of an item in such a way that every sample of the same size has equal chance of being selected. My example for this one is putting numbers in a hat. If you've got 30 people in the classroom and you want a sample of 5, you'll put all the names in the hat and pull out 5. You dump them all back in, mix it up, you do another sample, take out 5. Everybody has equally the same chance of being chosen. Systematic, we do every kth person, like every 10th or every 50th. So I visualize that as a great big long line, and then I choose every 3rd person or every 10th person. Convenient sampling, whoever's closest or easiest. Cluster, we divide the population into groups or clusters, and we select some of the clusters, and we talk to all the people within that cluster. If the cluster didn't get chosen, nobody gets talked to. If the cluster did get chosen, everybody gets talked to. All right, stratified sampling, we're still going to subdivide them into subgroups. They just give it a special name of strata. And then we draw a simple random from each strata. So everybody gets a chance to be talked to because all the strata are used, but only a small sample within the strata. All right, so again, here's some nice examples. So simple random, every sample of the same size has an equal chance. So you could just use a random number generator, or again, put names in a hat. Systematic, here we go. We're doing every third person. We're doing person 3, person 6, person 9, every case member. Convenience, just hollering at somebody out the window just because they happen to be close by. Good, here's our visual of the cluster. Notice we're sorted into 32 precincts, but we're just choosing 3 to talk to. The other ones, I don't even talk to anybody. I just choose from that particular cluster. That's how it gets its. Whereas stratified, all the people are chosen, put into strata, and then you take a few of each. Stratified is a way when you want to do gender, you would do male and female and then pick so many out of each one. That way you made sure you had both male and female in your sample if that was one of your goals. So stratified, break it into subgroups. Another way to do that, like in high school, you have freshmen, sophomore, juniors, and seniors. Stratified, you would take a sample out of each of those 4. Same idea on the freshmen, sophomore, junior, seniors. If you were doing cluster, say you'd only talk to the freshmen and the seniors. You wouldn't even talk at all to the other 2. All right, that's an example there. Okay, so now I want to go to the textbook. So pull out your book. You can pause this by just clicking on it and then resume. Just click again. All right, so we are on page 16. Yes. All right. Now, if you have your book out, you can see the instructions. So for number 4, we're talking about statistical literacy and critical thinking. So I have a sample of students, and a college statistics teacher conducts a study by recording whether each student in his class was right-handed. The objective, was to form a conclusion. Sorry, I just knocked my microphone. The objective was to form a conclusion about the proportion of college students that are right-handed. So what type of sample was obtained? Well, this is definitely convenience because the teacher just asked the students who were in the room, is it likely to be biased? No, not really. You can't change left-handed and right-handedness in any way. So it would be convenience, but it's not biased. All right, number 8, I was going to skip. I was going to do 7 and 8. The directions change, though. Here they ask, does it make sense? All right, so for number 7, does it make sense that a study must have been biased because it concluded 75% of Americans are more than 6 feet tall? Well, definitely, because we know that the average American height is closer to 5'5" or 6, and it doesn't even say male or female. So you are not going to find 75% of Americans above 5 feet tall. So it must have been biased. They must have talked to, perhaps the basketball players or something. So definitely a bias. There was a poor sample there. All right, death row. So now we currently have 3,242 convicts on death row based from the Bureau of Statistics. So that's not biased. That's just a statistic. We obtain a simple random sample by compiling a number of lists. Use a computer to do a randomly generated 20 numbers, or you could put them all in a hat and pull out 20. That takes too long. Between 1 and 3242. Then select the convicts that correspond to the generated numbers. So it's not biased. It's based on a simple statistic, and it is a good sampling method because it's simple random. I personally probably would have asked more than 20 people what their they don't even say what they want it for, but when I have 3,242 people, a higher sample is better, so I probably would have gone for a few more, but the way they did it was perfectly fine. It's not biased and it's simple random, so that's a good way of finding information. All right, for number 10, the directions again are census. Determine whether a census is practical in this situation. So for number 10, we want high school heights. You want to determine the mean height of all high school basketball players in the whole United States. Definitely not a good thing for census. That would be way too many high schools and way too many people. Now, if you just wanted to do the mean height of a local high school basketball players, that would be fine for a census. But when you want them all in the United States, too many. You would want to do a sample instead using one of the sampling methods. Let's see, number 14, Super Bowl. Here we've switched directions again. So here we want a representative sample. So we're supposed to identify the sample population and sampling method. Then comment on whether we think it's likely that the sample is representative of the population. All right, so for number 14, this is good practice from what we did last time. So during the Super Bowl game, Nielsen Media, all right, we know Nielsen is an unbiased company who does this for a living, so they're very vested in making sure it's unbiased. They conduct a survey of 5,108 randomly selected households. So there's my sample, the 5,108 selected households, which makes my population all households. Yep, all right, all households. Our method was they conducted a survey, so that's simple random. And they found that 44% have their television sets tuned to the Super Bowl. So that 44% is my sample statistic. All right, is it likely the sample is representative? Yes. They are not biased. They took a large sample. They did it in a good way in a simple random method. So yes, that would be a perfectly fine way of getting the sample, and it would be representative of the population. Now, I'm sure there's things you could think of to say, well, what if they this or what if they that? And in my classroom, we usually have a good conversation about this. One of the things I miss about being online here. All right, number 21, GMO soybeans. My directions here over for number 21 are there possible sources of bias for this method of gathering a sample? So Monsanto, we're assuming that's a company, hires independent university scientists to determine if its new genetically engineered soybean poses any threat to the environment. So apparently Monsanto works with genetically engineered soybean, so they hire independent university scientists. All right. A possible source of bias here would be perhaps this company contributes to the school, because we know local businesses a lot of times are contributors, or they give scholarships, that kind of stuff. So it may not be biased, but that is a possible source of bias. So you would have to find out whether Monsanto had any connection whatsoever with this university before you would want to go ahead and say that would be unbiased. So it doesn't mean it is, but it is definitely a possible bias. All right, now we're going to go down to sampling methods. This time I actually included the instructions because I wanted to do all of the 23, 24, 25, and 26. So it says identify which of the following applies. So which sampling method is it? Simple, random, systematic, convenient, stratified, or cluster? And in each case, do we think the procedure is likely to yield a representative sample? So say why, do we think it's that type, and will it give us a good representative sample? Okay, so for 23, we have a clinical trial. In a phase 2 testing of a new drug designed to increase red blood cell count, a researcher obtains envelopes with the names and addresses of all treated subjects. Okay, so we got them all. She wants to increase the dosage in a subsample of 12, so she thoroughly mixes all the envelopes in a bin and pulls 12 envelopes to identify the subject. All right, so that would be a simple random, because literally it's like putting it in a hat. Everybody has a chance. There's no bias because they were in envelopes, so she doesn't know who the people were. So this is good. All right, so it would give a representative sample, and it is not biased, and it is simple random. All right, 24, sobriety checkpoint. Police set up a checkpoint. Every 5th driver is stopped. All right, so 24, that is definitely systematic. Every case. Oops, give me a second here. Okay, sorry about that. So that is every 5th, so that would be systematic, and there's no bias. You see this all the time. Everybody coming through gets checked, so, or every 5th person in this case. So And you'll assume they're going to set up somewhere, like not right outside a local pub. Maybe they will. All right, but it's a good way of doing a sobriety checkpoint. All right, exit polls, number 25. On days of presidential elections, the news media organize an exit poll. So if you have voted, you've seen them, in which specific polling stations are randomly selected and all voters are surveyed as they leave. Okay, so we have a subset, or we've organized into polls, but we took all the voters from only a few. That's going to be cluster. Yes, that could be some possible bias depending on where that exit poll was located. So you would have to check the geographic location, like if they were all in a particularly affluent community versus particularly rural or inner city. So you'd want to make sure that possible bias could happen if all your exit polls were done at a polling station that didn't give a good representative of the population. All right, number 26, education and sports. So here we have a researcher for Spalding Athletic Equipment Company is studying the relationship between level of education and participation in sports. Interesting. She conducts a survey of 40 randomly selected golfers, 40 randomly selected tennis players, and 40 randomly selected swimmers. Okay, so this time that is stratified. She's stratified it into golfers, tennis players, and swimmers, and taken 40 of each. So that would be stratified. I do not think it's a good representation, though, because she just wants to do level of education and sports. She only chose 3 sports. So that's not a good representation of people in sports. There's no football, no baseball, no swim. We did do swimming, etc. So not a good representation, but it was a systematic method. Okay, that is the end of section 1.2. So please go work on the homework for that and email me if you have any questions. Thanks so much. Bye-bye.